So in math, a lot of times you start off by defining things at a point. Okay? We talked about what it meant to be continuous at a point, and then we talked about what it meant to be a continuous function. Okay? In the last section, when we just finished, we talked about how do you find the derivative of a function at a point. Now we're going to talk about how do you find the derivative of a function, which is going to be itself a brand new function. Okay? So in the last section we discussed the derivative of a function at a point, stating that the derivative of f at x equals a is given by this expression right here. Okay? You should be getting sick of seeing this expression. Okay? What do we write provided the limit exists? Okay? Some new vocabulary then. Okay? For some reason, I've had students just really not like this word. Fair enough, but let's go through it. I want to be able to say what it means for the derivative to exist, because the derivative is not always going to exist. So if you're able to find the derivative, meaning if this limit does exist, we're going to say that the function is differentiable at that a value. So we're defining what it means to be differentiable. Okay? So I'm not talking about some part of a car or something like that. Okay? I'm talking about what it means to be able to compute this limit, because we've seen before, limits don't always exist. If you can compute this limit, then the derivative exists. But how do we say that? We say that the function is differentiable at that point. Okay? We can then extend that definition larger. If f prime of x exists for every a in an interval, meaning f is differentiable at all a values within an interval, then we'll say that f is differentiable on that interval. Okay? So we're extending it. So we said, okay, what does it mean to be differentiable at a point? It means that that limit exists for that a value. What does it mean to be differentiable on an interval? It means that you can find the derivative at every single point on that interval. Okay? If it's differentiable on the entire real line, then we could say that f is everywhere differentiable. Or just f is a differentiable function. So if I say the function is differentiable, what do I mean? At every single point on the number line, you can compute its derivative. So we're now shifting gears. Okay? We've been talking about derivatives point-wise. What does it mean to be differentiable at a point? We're now going to say, given a function that's differentiable, how do we compute its derivative? That's what we want to talk about. So suppose f is differentiable on an interval. Then we define a function, f prime of x, called the derivative of f. Folks, what am I not saying? I'm not saying the derivative of f at x equals 3, or the derivative of f at x equals 27. I'm talking about this new function that's called the derivative. Okay? So we're not talking at a point. We're talking about a new function that we can create. And the definition of this derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. He just keeps writing the same expression over and over again. No. Is this the same expression as before? Is this the same definition that we put up here? What's the difference? Yeah, it's not at a point. What does a stand for here? A stands for some fixed number in the domain. X is a variable, as it's always been. So we repeat the procedure, but we use x as an arbitrary number as opposed to a fixed number. Okay? This is absolutely critical going forward. It's absolutely critical that you realize that f prime of a returns a what? What type of object? At its most basic level, what type of object is f prime of a? It is a slope, but what a slope is a what type of object? What's that? No. It is the slope of the tangent line at that point. It returns a value or a number, right? When I say f prime of a, you're expecting to see a number, right? The slope of the tangent line at x equals 7 was 25. The slope of the tangent line at x equals 3 was minus 7. You're expecting it to return a number, i.e. a slope. Well, f prime of x is what type of object? It's a function. Okay? So folks, this is a good place to start learning this skill in math. There are a lot of different critters, math critters out there. You need to be able to start classifying them. Is f prime of a number or a function? It's a number. Okay. Is f of x a number or a function or an operation or what? It could be many different things. So you want to be able to start classifying these. All right.